So this was the pop quiz 6, which was related to electricity and magnetism and mainly electric circuit questions. So in the first one, question 1, figure 7.1 shows a circuit that contains a battery, a switch, a voltmeter, and three 40 ohm resistors, R1, R2, and R3. The switch is open. Resistors R1 and R2 form a potential divider. What is meant by a potential divider? So, what is the meaning of a potential divider circuit? The circuit which divide the potential or the voltage, which consists of components connected in series and divide the voltage. So we call that as a potential, divide the voltage between the component, we call that as a potential divider circuit. Then the reading on the voltmeter is 7.5. Calculate the electromotive force of the battery. So if you want to calculate, as I mentioned, each is of 40 ohm and this switch is open. So when this switch is open, this is not part of the circuit anymore because the switch is open. So there is no current here. So we can ignore this component. R3 can be ignored. So if we ignore R3, so it means R1 and R2 are there, and R1 and R2, they mention each resistor is having a resistance of 40 ohm. So this is 40 ohm, this one is also 40 ohm. So when we have and the reading on the voltmeter is 7.5. So if we have the two components connected in series, so the voltage will divide, if they have the equal resistance, the voltage will divide equally. So this was having a voltage of 7.5, this will also have a voltage of 7.5. So if the two have the voltage of 7.5, what is the voltage of the supply or the EMF of the supply? That will be equals to 15 volts. So when the switch was open, R1 and R2 was in series. So the voltage across the R1 should be equals to voltage across R2 as they have the equal resistance. They have the same resistance or equal resistance. So if one of the component has a voltage of 7.5, the other should also have 7.5. So the combined voltage or the EMF of the supply should be 15. So that will give us the EMF as we have to predict the EMF of the first part. So EMF will be equals to 15. The switch is closed. Calculate the resistance of complete resistance of the circuit. Now we close the switch. So this switch is closed now. So this R2 is 40 ohm, R3 is also 40 ohm, and R1 is 40 ohm. But R2 and R3 are connected in parallel. So when two components are connected in parallel, what's a combined resistance? It's a product divided by sum. So when we simplify, we'll get 20 ohm. So the combined resistance of these two, the combine of these two is equals to 20. And if this is 20 and this 40 ohm is connected in series with this parallel combination, so in series, how we find the total resistance? So it will be only sum them. So 20 plus 40, the combined resistance of the circuit is equals to 60. So first what we did, we find the combined resistance of parallel combination, which is a product divided by sum. And then we add the resistance of the component connected in series. So that's why it is 20 plus 40. So the combined resistance will come out 60 here. So this will be 60. But don't write the direct answer. You have to show you're working like first you did 40 multiplied by 40 divided by 40 plus 40. That will be 20 ohm. And this 20 ohm plus, like first we find the combined resistance of R2 and R3. And then we are finding a combined resistance of R2, R1, R2 and R3, which is 20 plus 40, which will make 60. The next, calculate the reading of the voltmeter when the switch is closed. So we want the voltmeter reading here when the switch is closed. We know the total voltage of a total EMF is 15. And we know the total resistance of this circuit, the total resistance of the circuit is 60, the combined resistance. So first what we'll do, we'll find how much current, because when the current will enter, it will divide in the parallel and it will be same in series and it will return back. So we'll find the current here, how much current is, what is the total current, and from the total current, we can work out, from the total current, we can also work out the voltage across the component by using a formula V equals IR. There are two ways to do this. First is find the total current of the circuit. How to work out the total current? I equals V over R. So total voltage is 15 and total resistance of the circuit is 60 and when the switch is closed. So 1 by 4 or 0.25. So 0.25 ampere is a current which entered the circuit. So that 0.25 will flow through R1 and the resistance of R1 is 40 and the current is 0.25. So if you need the voltage here, V equals IR, the current is 0.25 and the resistance is 40. So 40 multiplied by 0.25, that will be 1 by 4 of 40, which is equals to 10 volts. So the reading will be 10 volts. This is one way of doing this question. There's also another way of solving, that is using a concept of the potential divider. In a potential divider circuit, like this part has a total resistance of 20. And this part has a resistance of 40. And the total EMF of the supply is 15. In a potential divider circuit, if I need the voltage across the one component, that is resistance, if I need the voltage across that component, I call V1, resistance of that part divided by the sum of the resistance of the two component or the total circuit resistance into combined voltage into total voltage 15. Into total voltage. So this, when we simplify, it will be 40 divided by 60 into 15. It will also give us 10. If I need the voltage across this component, then the combined resistance of this part, which is 20, divided by the sum of the resistance of the circuit, 20 plus 40 into combined voltage, 15. So, and this will give us 5. Because if the total is 15, if 10 volts is here, remaining 5 volt will be across R1 and R2 and R3. So you can use a potential divider formula, like a voltage divider formula, or you can also find the total current in the circuit. And the total current in the circuit is same as the current in R1. So you have the current and you have the resistance. So you can also work out the voltage. So both ways are acceptable. You can use a potential divider, or you can also first you find the current, the total current, and then the using a formula V equals IR, you will find the total voltage. So this was a pop quiz 6, which was related to electricity and magnetism.